Okay, in this video, we are going to do the position, velocity, acceleration, ground reaction force, in the vertical direction for the squat up movement. So we're going to start, this is just a little picture, in the low position, or the person will start in the low position at time 1, and then end up standing upwards, standing still. That's terrible. Time 2. So going from a low position just to start standing up. All right, so this is just my brief description of the task. You'll want to make sure that you've watched the squat down as well as the introduction to ground reaction forces prior to this one, because I'm going to go a bit faster in this one. So here's our position, vertical position versus time plot, vertical velocity, vertical acceleration, and the vertical ground reaction force. All vertical. Up is positive as our standard reference frame. I'm going to start in the low position and stand upwards and stop in the standing position. So this would be T1, this would be T2, corresponds with those cartoons. And drop those dotted lines down. And I'm going to drop it all the way down to each plot so we can line these up. Okay, so I just drop those lines down all the way. All right, so first thing, let's look at the movement throughout here is all upwards. All these slopes along here are all positive, so velocity will be positive throughout. We have speeding up, moving upwards. We have slowing down, moving upwards. Speeding up, moving upwards, slowing down while moving upwards, and then stopping. I'm going to drop a dotted line down at that peak. It's a little easier to draw some of these so they line up well. This is all, this entire movement is up. We have speeding up, moving upwards. We have slowing down, moving upwards. Let's do our acceleration. All these slopes are positive, therefore accelerations will be positive. All these slopes are negative, all accelerations will be negative. Rate of change of velocity is increasing as the slope gets steeper. Rate of change of velocity is decreasing as the slope gets less. And eventually goes right through 0 at that point. Rate of change of velocity is increasing as the slope gets steeper, negative. Rate of change of velocity gets less steep as the slope is negative as well. So my acceleration profile will look something like this. Acceleration is 0 before and after because velocity is constant, and in this case velocity is 0. All right, so now I've got my acceleration profile. Now I want to set up my model for ground reaction force. And I'm going to write the equation down that we derived in a previous presentation. Ground reaction force is equal to MACOM plus FG. That's a constant. Mass is a constant. The ground reaction force and acceleration will vary the same. They will, the ground reaction forces causes the acceleration. And remember, this was from the squat down presentation. If acceleration is negative, the ground reaction force will be less than gravity, which is less than body weight. If acceleration is positive, then the ground reaction force will be greater than body weight. And you go back to the previous presentation just to double check that math. But anywhere where you see acceleration is positive, anywhere, the ground reaction force will be greater than body weight. Anywhere where acceleration is negative, ground reaction force will be less than body weight. Anywhere where acceleration is 0, ground reaction force will equal body weight. So let's start with that. Okay, this is all body weight, FG. And anywhere where acceleration is positive, ground reaction force will be greater than body weight. Anywhere where acceleration is negative, ground reaction force will be less than body weight. This is 0. Ground reaction force will always be positive for the vertical movement, as long as our feet are not fixed to the ground in any way. These are all positive ground reaction forces. In this region, ground reaction force is greater than body weight, because here's body weight right here. In this region, ground reaction force is less than body weight. When ground reaction force is greater than body weight, acceleration has to be positive in order for that equality sign to be true. When ground reaction force is less than body weight, acceleration has to be negative in order for this equation to be true. This is all upward movement. So let's not forget, the direction of acceleration vector does not indicate direction of motion. It simply tells us the direction of the velocity versus time plot, so the slope of that. This is all upward movement. So these are all mathematically related. So if I go on my force platform and you'll watch a video on that, and I go from a squat position to a standing position, this is what my ground reaction force should look like. Okay, thanks.